Today's lesson is on rational numbers. But before we jump into the lesson, let's have a little riddle. Why do bees have sticky hair? Why do bees have sticky hair? Because they use honeycombs. Ooh, okay, I thought that was cute. Okay, we're going to look at the real numbers first. You don't need to write this down. The real numbers are made up of natural numbers, also whole numbers, integers, and then more specifically, we're going to look right here at the rational numbers. We know the natural numbers. This is how you learn to count when you're a kid, 1, 2, 3, and so forth. The whole numbers just add 0, and integers are the positive and negative whole numbers. Rational numbers also include fractions and decimals, and it's any number that can be written as a fraction, A over B. Remember that you can't divide by 0, so B can't be 0. And when we start writing these numbers, you can't put decimals or fractions in the numerator or denominator. It's not considered proper, and I'll show you how to fix that later on. Also, there are irrational numbers. So you're either rational or irrational. By the way, all of these are rational numbers. You can write 5 as a rational number. All you got to do is put it over 1. Now it's a fraction. So all of those are considered rational. Examples of irrational numbers, include numbers like pi or e, which we call transcendental numbers. They represent something like the circumference divided by the diameter. But even radical 2 and radical 17, these are what we call irrational numbers. And an easy way to know that it's irrational, or meaning it cannot be written as a fraction, is in its decimal form, it never ends and it never repeats. Okay, so a decimal that ends or repeats, you can consider that a rational number, but we would have to write it as A over B. In example 1, we're going to practice writing each number in its rational form, meaning we're going to write it as a fraction. No mixed numbers allowed, just A over B. So here, -4, we could write that as -4 over 1. There we have it, all done. How could we write 0.25 or 25/100ths in rational form? That would be 25 over 100. If you count the decimal places, that's how many zeros you need here. So that's a 1 with 2 zeros. However, we must reduce it. 25 goes in here 1 time, and 25 goes into here 4 times. -3 1/5. Well, we don't want mixed numbers, so we're going to write this as an improper fraction. Remember, in elementary school, we multiply 5 times 3 and add the 1. So that would be 16 over 5, and then we put the negative on there. Is this reduced? Yep, already reduced, so that's as far as I can go with that. What about 7/10? Well, that's 1 decimal place, and if you listen to how I said it, 7/10, 7 over 10. Can I reduce it? Nope, I'm done. Ooh, What about this decimal that's repeating? 0.7 repeating, 777 forever. Well, hopefully you recall that if a decimal repeats, we put it over 9 instead of 10. Later in the year when we learn sequences and series, I'll give you a formula that actually proves that this is the case. So 7 over 9 is how we write that in rational form. And if you were to punch that in the calculator, you'd see. The calculator would probably give you an 8 on the end. When it runs out of spaces, it usually just rounds up. Now, what about 0.12 repeating, like 0.121212 forever? That's 2 digits repeating, so we will put that over 2 nines. Can that be reduced? Yes. 3 goes into the numerator 4 times, and 3 goes in the denominator 33 times. So never forget, you must reduce always. Now, let's look at some identities. Okay, we're changing tracks for a moment. Just trying to review a few things that you'll need this year in Algebra 2. The additive identity and the multiplicative identity. You don't really need to know those names. What you need to know is that you can always add 0 without changing the value. And you can always multiply by 1 without changing the value. For example, if I add 0 to 7, I'm still going to have 7. Let's come up with a better example for the multiplicative identity. What if we have 2 over radical 3? Well, we learned that you can't have a radical in the denominator, so I'm going to multiply by 1. But this one, I'm going to make it a little cute. So I get 2 radical 3, and on the bottom I have radical 9, which is just 3. See, 3 times 3, that's the square root of 9, which is just 3. Okay, let's make sure we understand these two terms, opposite and reciprocal. Now, these are tied to the identities. Notice this is our identity right here for addition. And this is what we call the opposite. So if I gave you the number 5 and I said, what's the opposite of 5? Well, the opposite of 5 is negative 5. What's the opposite of negative 5? Positive 5. All you do is change the sign. Now the reciprocal is this right here. The easy way to think about it is flipping the fraction upside down. And this is the multiplicative identity. Again, you don't have to write all that down. You just need to know how to find the opposite, how to find the reciprocal. So if I ask you the reciprocal of 2, well, that's just 1/2. So you might just put it over 1 so you can see what to flip. Or the reciprocal of negative 2/3 is negative 3/2. Okay, so you flip it, but you don't change the sign. That's very important. I always have people that want to change the sign. Okay, you just flip it to find the reciprocal. Let's practice finding the opposite of each number. For 14, change the sign, negative 14. That's the opposite. The opposite of negative 7 over 4, positive 7 over 4. Just change the sign. Now, the opposite of 2.5, negative 2.5. So that's the opposite. Now let's move forward and practice finding the reciprocal of each number. The reciprocal, again, is telling you to flip the fraction. Flip it. So that'll just be 3/2. Don't change the sign again. Now here, before I can flip a fraction, I need to write it in rational form. So remember, we multiply 2 times 1 and add 1. So 2 times 1 is 2 plus 1 is 3. So this is equal to -3/2. And now I'm going to flip it. Notice my number still stays negative. Just flip it. So that's the reciprocal. Ooh, I need to write this as an improper fraction. So that'll be 2 1/10. Multiply these two and add that. So that's 21/10. Now I can flip it. 10/21.